So good morning, everyone. On behalf of 𝗽𝗶𝗁𝗲, I would like to welcome you to today's webinar, how to optimize paint dosing with 3D printed nozzles. This session is part of our ongoing commitment at 𝗽𝗶𝗁𝗲 to innovation in coatings manufacturing equipment. Today, we will be sharing insights into how 3D printing technologies are helping us design and implement the smarter filling solutions. We have two excellent speakers, as you can see here, 𝗍𝗫, 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 thank you for being today with us. They will guide us through both technical innovations and practical experiences. The chat will be open throughout the webinar, so please feel free to send your questions at any time. Once both presentations are finished, I will pass your questions on to the speakers for them to answer. So then we are going to start, and first let me introduce 𝗍𝗫 from 𝗽𝗶𝗁𝗲. 𝗍𝗫 is a key figure in our engineering and product development team. He is going to take us through the technical side of how we are using 3D printing to improve dosing processes, with a focus on cycle time optimization and nozzle design. So 𝗍𝗫, thank you very much for being here with us. You could proceed with your presentation.
Okay, thank you, Carlos, for your introduction. As Carlos said, I'm 𝗍𝗫, the filling product manager of 𝗽𝗶𝗁𝗲, and I will try to explain how we are optimizing the filling process in the filling equipment. Okay. Then the presentation is based on the 3D technology, and there is one basic that from the starting we have to take in account is that how we are getting the cycle time of one filling machine, that it works step by step. Okay, there is two concepts that we have to take in our mind that are related one to each other. It's the transport time and the dosing time. It doesn't mean that these two cycles of these stations are the only ones. In the filling machine, we can have several stations, as for example, the lead dispenser, anti-skin process, inlet feeding containers on the machine, closing station, capping devices, or whatever. But we know from our experience that the longer stations that we are processing, it's the transport and the dosing. In this video, we can check, we can observe that we cannot reduce this cycle time because one process is completely related with the other one. I mean that you cannot start to dose if the bucket is not transport and stop it. Okay, this is a restriction. Then take a look that, of course, first we move the bucket is stopped, and then we can start the dosing. This composition of these times are giving to us the cycle time. Okay. Then, on that slide, we are separating both processes as the main restriction, as we said, of the cycle time. In the left side, we can see here the transport movement of the buckets during the transporting over the conveyor track, and on the right side we can see only the filling process. Okay, that both of them are very important. Okay, today we can consider that the transport time with the technologies that we are using are mostly on the limit. Then if we have this cycle time, it means that if we are saying that the transport time is mostly on the limit, we only have one variable to play to try to save time, and then as a consequence to improve with a reduction the cycle time. But to get this challenge, we have to consider some of the multiple variables that we have on the filling equipment. We have variables as the buckets and the tins. Also, there is another important factor that this is the product that we want to fill. In combination of both of that, we are creating some restrictions. For instance, regarding the buckets or the tins, there is one basic of the restrictions that it could be that the bucket could be cylindrical or conical. It could be also plastic or metal. These geometrical definitions of the bucket, it's affecting to us in the transport and it's affecting to us on the dosing. In the transport, how it's affecting the geometry? It could affect on how we can control the wave that we are creating on the movement of the bucket. And if we have a tin like we are observing right now, we can speed up the transporting on the bucket. Okay, here with the plastic and conical cylinder, and in the conical bucket, it's more smoothly the transporting. Also, there is another big important parameter that is the height that there are in between of the rim of the can to the limit of the level of product inside of the bucket. Okay, these two parameters, it's helping to us to speed up or not the conveyor speed on the dozer, on the conveyor track. Then for the dosing time, the same parameters that we have, consider it if it's cylindrical, it's conical, it's plastic, metallic, and also the rheology of the product, it's affecting a lot in how we can improve, reduce in terms of quality, in terms of speed, the effect of the dosing process. Okay. Also, of that important restriction that we know from experience is that on the filling process there is a huge of problems that for us it's so evident as a manufacturers of the filling equipment and using paint and coating technologies, that we know that it could happen on the filling process, and these effects we have to control it, okay, because it's affecting how we will finish our filling processing. Okay, if we have some air entrained on the paint, we can create splashes during the filling process, or even when we are running very liquid products, this PAM effect, when we are closing the valve, we are splashing around the nozzles, and we are creating splashes surrounding the bucket. The capillarity, it's very important to avoid to create any spot on the buckets in the between of the movement. Then this is not acceptable to have it on the machines. No, then all of that effects, it's something that it happened on our filling process, and we have to try to reduce it as much as we can. Also, there is another effect that it could be the foaming process in a very liquid process. Then all of that restrictions are giving to us a challenge and a source of inspiration that how we can improve our technology or capacities to try to reduce all of these effects that we are showing to you. Okay, and it's evident that with the traditional manufacturing process that we have, it was very limited because there is a lot of restrictions using materials, using the machinery to get the final nozzle that we are looking for. It's a barrier that we have. No, then after analyzing this challenging, we observe that maybe we can think about what we have in the market to apply it in our products. Then in the market there is the 3D technology that it's giving to us a new world in terms of design and capabilities. Okay, because as we said before, the traditional manufacturing, it was so limited, but in the 3D additive manufacturing system, you can try to do whatever you want. You will see later, but in fact, this is a very nice sentence, but there is a lot of restrictions that you cannot do whatever you want. There is some limits that you have to take it in account to get what you are looking for. Okay, but our basic, it was to try to use this technology just to adapting the designs for each need of our customers, how to improve the quality of the final product. Okay. Then what we did is go to the market of the 3D printing, okay, and check what is the current technologies, because this is a new potential solution, and we try to do it to use it as a challenge. No? Then this technology that there is in the market today, it's a market that it's the evolution of this market. It's so fast in terms of restrictions, in terms of materials, evolutions, and so on. And we have to be really, really close to the market in a loop, continuous loop, developing and trying to research potential new solutions, and using these 4 technologies that there is in the market. Fused deposition modeling, the FDM technology, is the most common technology nowadays. I think that all the people has at home at least one 3D printing machine just to fuse some small parts. Okay. There is also the selective laser melting technology that is for the basic to produce 3D metal parts, that it has this technology focus on that. Then the stereography technology is using a pool with resin, with a lamp, creating layer by layer a product. This technology needs to have some supports to avoid that this technology or the part that you are printing is collapsing in the meantime that you are producing. And then the selective laser sintering, it's based in the powder, and with the laser we are making the layers and so on. All of that technologies, we have to take a very important point, how we can take the benefits and the pros and cons of this technology, because there is variables like the cost, limited materials, resolution of these technologies that there is in the market, mechanical strength, how it will be the strength, the material, the part that you are printing, selecting which type of technology you want to use, and also the post-processing process after make this part. Okay, it means that what you have to do once you are getting this 3D part to get it as a final part. Okay, this is only the restriction that there is in the market with the technologies that they are currently in the market, and which one of them we can select it. Okay, then this is what we observe. It was focused on the 3D printing market, and this is more reduced in our paint and coating market. Okay, because here we have to take in account that we are handling products with solvents. We have to comply the ATEX certification or regulation to avoid that we are not creating some gaps in terms of continuously of the material, and then all of that restrictions linked with the technologies that we have are creating to us a high barrier in terms of technology that we have to select, okay? And especially one of the parts that we are saying is concerning the tubes that they are creating, the nozzles. If we are selecting a wrong technology, we will not create these perfect tubes to guarantee the capillarity process, okay? Then it's not so easy and evident decision to select which one of these technologies that there is in the market to be selected, okay? Then focus right now on how we are designing and how we are getting this magic solution from the 3D printing nozzles. We are making this schema, this 5 process, to get the final result that we are looking for. The first step is the nozzle design. We are using a 3D system, okay, that we are trying to develop our concept idea, and we are modeling on the screen, okay? This modeling, of course, must be related with some calculations that we want to be looking for. I mean that sections, speeds, capillarity, viscosity that we want to guarantee, speeds, and all of that calculations must be related with the design that we have done on the nozzle design, okay? If this nozzle design is accordingly with the calculation, then we can go to the next step, that this is the simulation process. This simulation process that we are doing, we are using a CFD simulation process, that what we are doing here is just, okay, taking our principal design of the nozzle, our idea is to create some effects. And these effects that we are trying to get, we want to check it before to be printing the parts. We want to check that what we have in our minds is what the CFD simulation system is getting to us. If this CFD systems is not related with our concept design, then maybe what we have to do is to redesign our principle of the nozzle. But in our first iteration, what we will do is, okay, we have the 3D design, and if the simulation is according to what we have considered in the simulation, then we will go to the manufacturing process with the 3D printing design. Then once we have this 3D printed nozzle, we are going to our filling test machine, and we are placing this nozzle to this dosing station. And then this is the key point, or the most critical point, okay? Then on that scenario, we have to get the final result on the test must be equal, or the most equal possible, with the simulation of the for the CFD simulation process. If there is a big gap in between on the real life or the simulation process, our design conception and simulation is not right. Then what we have to do is to align the real results with the simulation and the nozzle design. And these 3 concepts must be linked one to each other to get what we are looking for, okay? And also it's very important to have it aligned, the product that we are making or that we are testing in the simulation, because if we are finding the perfect balance in between design, simulation, and test with the product, then for next iteration or for next concepts of nozzles, we will get faster results to do some trials or some new 3D printing nozzles to be applied in the market, okay? If we know how works this paint through the nozzle, then the effect that we were describing before regarding the rheology of the product, geometry of the bucket, and so on, we will control it in a better performance, and we will get, or we can iterate in a different nozzles. Okay. Then, as a conclusion, because till now you have to trust in all of our explanations, but I think that this video is helping to us to understand, because this is a physical evidence that we are getting in our test machine, that how is affecting the design of the 3D nozzle machine, no? Because here on the first corner, that one, we have that conventional nozzle, okay? I missed the video. It seems that the video it's frozen. It could be.
Yes, Sergi, the video is frozen. Perhaps let me try.
Okay, I will go back.
Now. Oh, no. I think that now you could see, right?
No, I will try to go back. Okay. Okay, now it works again. Sorry. Then here, you could see that this is the conventional on the left side corner. This is the conventional nozzle. Okay, working. All of them are working in the same parameters in terms of speed, acceleration, and deceleration, and you can observe how it's affecting the design of the nozzle. We have big splash in some of them, then we have some drippings, how we are creating some air treatment in between, and everything of that process is a real evidence that according the design that we are doing, take a look, that one, it's so evident. I will go back here, how is creating this big splash of paint using the same, I repeat, the same parameters in both of them, how it's affecting the splash on the paint, even the dripping, air, and so on. Then this slide, it's showing to us how important it is, the design of the nozzle, because this concerns appears based on the 3D technology that we are applying, because with the traditional manufacturing process, we never find something like that, because we are making straight tubes with a limitation of length and diameter, because we have to manufacture. Here we can use different geometries, different materials, and different concepts that we are giving to us more tools to improve this process. Okay, then another example is that one that I think that is one of the most insane examples that we can show to you. Again, this is water. This process, and we are filling the same container, the same tin, at the same parameters. And here in the left side, you have the standard technology or the traditional technology, and in the right side, you have the 3D technology. The upper part is in brush, but inside you have the 3D printing nozzle inside that you cannot see on that video. But now you will see the difference that there is in between. Okay, I put it again. I think that this clip is showing to you how important it is. I repeat it, same speed, same acceleration, same deceleration, how it's affecting the quality of the dosing. First point. Second point, the speed. Okay, what we can do just changing this part. Okay, this is showing to us how important it is, the design of this technology. Also, you could see here the amount of product that is over the rails or over the conveyor track, showing that the importance of this technology. One important thing also is that the 3D printing technology, it's helping to us to guarantee some of aspects that today we know from the market. The 3D traditional technology, we know that these parts are so expensive. The maintenance to guarantee the perfect maintenance of these tubes and that they have no damaging, the weight that have this part and so on, how you have to maintain this element, it's so critical. Okay, and then using the 3D printing technology, we are considering that perhaps this technology, it's helping to us to bring to the market these nozzles as a spare parts, simple, just to be dedicated for each product according the product or the bucket that you want to fill. If you have a new product to be filled with an existing machine, how we can try to fill something that today we cannot fill it. Okay, we have some requirements from customers that they want to fill a new product in the market, that they have this new inquiry, and with the machine that they have, they cannot fill it because they are a big splash. There is no control in the dripping, or the quality or the restrictions of the bucket, it's so high. Then with this technology, with this knowledge, with all of the processing that we have, design, calculation, CFD, simulation process, and test, we can check what is the optimal solution to guarantee a good dosing process. Okay, and the last slide that we want to show you how it looks is one inquiry from one customer. Okay, that they ask to us to get a new nozzle, that they want to find one nozzle that is giving to the customer a high quality on the coating of the paint. They are looking to guarantee a high quality process for the dosing, with no drips and easy to remove from one product to another one. And this is a clear example how it could be the quality that we can get according the product, according the bucket that you want to fill, and according also the speed that you are looking for. Okay, these three concepts in a balance are giving to us these results that with the traditional manufacturing system, we cannot get it with the same quality that we are observing right now. Okay. Okay, I think that from my side, more or less, this is the part that we would like to explain to you, and it's very, very important to you, that I hope that everything is clear. If not, you will have the time to make the questions that Carlos will transmit to us in a later stage. Okay.
Thank you, Sergi. Thank you very much.
Thank you to you.
I found your presentation very, very interesting. Thank you for that. So if I have to summarize your presentation in one sentence, maximum two sentences. I have to say that you explained how 3D printing offers us new possibilities for customizing and improving nozzle designs beyond what's possible with traditional manufacturing. And secondly, you walk us through Oliver Battle's development and design process, highlighting how we integrate these technologies to create nozzles that improve dosing speed, accuracy, and also reliability. So now it's time for our friend Sila. Sila, thank you very much for being here with us. Sila is our second speaker. Sila Taman from AkzoNobel in Turkey. Sila will share her experience as an end user, especially how AkzoNobel's plan in Turkey has implemented and tested one of these 3D printed nozzles on their production line. So Sila, thanks again. It's your turn. You could proceed when you are ready. Thank you.
Thank you, Carlos. Hello, everyone. I'm Sıla. I'm currently working as a gate engineer at AkzoNobel Paint Company. I have a background in chemical engineering, and I'm based at our cie factory in the Netherlands, where I continue to build my professional experience. First, I would like to thank you to 𝗍𝗶 for inviting me this valuable webinar. It's a great pleasure to have the opportunity to share our challenges we faced, as well as the successful solutions we've achieved in a forum like this. Today, I will be discussing a critical challenge we encountered in production process and how close to collaborations with 𝗍𝗶 enabled us to overcome this problem successfully. Before diving into the topic, I would like to briefly introduce our 𝗍𝗫 site. As you can see in the pictures, our 𝗍𝗫 plant located in Turkey, and it's quite a large site. It focuses on producing decorative paints. We have a total 7 filling lines, 2 lines dedicated to solvent-based products, 5 lines dedicated to water-based products. In addition, the site produces a binder of water-based products. In solvent-based area, we operate 2 filling machines supplied by 𝗍𝗶, and also we have 𝗍𝗶 machines for water-based area, which is why we have close cooperations with them in our filling line. Before I go further, I would like to clarify that the experiences I'll share today took place at our 𝗍𝗫 decorative factory in Turkey. We can go to the next slide. Thank you. The main issue was we faced in filling solvent-based products characterized by expectationally low viscosity. The product's viscosity and density were even lower than the water. As you can see on the table, our density and viscosity data. This unique property created significant challenge during the filling as the process became highly sensitive and difficult to control. In initial trials before implementing the new nozzle developed by 𝗍𝗶, we consistently experienced splashings and dripping. Due to the high flow rate, it was extremely difficult to stop flow cleanly and adjust the fill volume accurately. To ensure problem wasn't related to our machine, we carried out a thorough review of the machine settings and performed detailed inspections to check for leaks or mechanical faults. However, we found no machine-related issues. This confirmed that the challenges were entirely due to the product's low viscosity and the inherent difficulty in controlling such a fluid during filling. We also tried reducing the filling speed, but even low speed rates, splashing and dripping continued. So this made it impossible to fill products correctly without any dripping or splashings, and we simply couldn't run the products reliably on our production line. At this point, actually, as you can see on the videos, the product splash and drips continues during fillings, creating significant cleaning challenge on the line. In many cases, the product wasn't even properly deposited into the can. This not only resulted in product losses, but also posed serious risk in terms of cost efficiency and quality assurance for us. During this period, we tested various types of nozzles, various types of nozzle designs, but none delivered satisfactory results. Neither change in nozzle geometry nor adjustments in filling parameters managed to solve the problem. It was then that we reached out to OB for help. After a site tour, a detailed review of our process, their team observed our problem in first hands. Based on their assessments, they recommended the testing their newly developed nozzle design. Could you please change the slide? Yes. This specialized nozzle came into two sizes, one optimized for 2.5 liters and the other one optimized for 7.5 liters. As you can see on the pictures, a unique feature of the new design is the presence of fine wires inside the nozzle. Actually, to be honest, initially we were concerned that these wires might worsen dripping because in many industrial applications, inserting wires, sponges, or similar materials into the nozzles is sometimes used reducing the splashings, but often cause a dripping problem. However, the OB design provide to be quite opposites. These wires effectively control and interrupt the flow in a way that prevented splashing entirely, while also eliminating dripping. Thanks to new design, the filling process became smooth, clean, and highly precise. I also prepared another video. Can we change the slides? Yes. Sorry for the voice. I also prepared videos demonstrate the filling process with both nozzle size, as you'll see. First one is 2.5 liters and the other one is 7.5 liters. These results was incredibly satisfying for us. Thanks to this breakthrough, we are now able to fill our low viscosity solvent-based products reliably without any complications. Furthermore, the cleaning workload on the production lines has been greatly reduced. Product losses have been minimized, and the overall quality of filling operation has significantly improved. Now we are also planning to extend our trials to similar nozzle design on low viscosity products in water-based area. Finally, I'd like to emphasize that this remarkable improvement was only possible thanks to strong and constructive cooperations we had with OB through the process. I would like to thank once again to OB for their technical expertise, innovative solutions, and ongoing supports. It's been a great opportunity for me to share this experience with you today. Thank you very much for your all attention and interest. From my side, I think that's all.
Sila, thank you. Thank you very much for this inspiring explanation and presentation. You gave us a practical perspective, sharing a novel Turkish experience with testing one of these 3D printed nozzles on your filling line in a real conditions. So and you covered what the objectives of the trial were, how the nozzle perform in a real production conditions, and the benefits and challenges identified during the testing phase. So thank you very much. So Sergi, I invite you to join us, and you also, Sila, because we have finished these two presentations. Now it's time for questions and answers. So I invite you for all the audience to send your questions through the chat. Here we have some questions, and of course, Sila, Sergi, I've also prepared some questions for you. So the first one is how this will affect the pumping group systems. Perhaps it's a question for Sergi. How do you consider that these new nozzles could affect to the pumping group systems, Sergi?
we have to take we have to understand what is the pressure that we will use on the pumping group systems. Okay, we have to know the flow rate, if it's increased or not, and also the pressure that we are applying to this nozzle. Then if we are increasing the pressure on the nozzle, we have to consider, then it's something that we have to evaluate it once we have to do this improve.
Perfect. Thank you. The second question is, can the slides be sent out after this, please? Yes, of course. So in fact, this webinar has recorded, and the presentation will share also in our social networks and LinkedIn and through other ways. There are another question. Is this technology available for purchase, or is it still in the experimental phase? So perhaps this is a question for me as a sales director, or in between in Sergi's and I. So now is in the R&D phase. So we expect to launch this technology to the market in the beginnings of the next year, right? Now, I have here some questions that I prepared in advance. So, for instance, one for you, Sila. What's the most noticeable benefit during the test at ACZO in your plan in these real conditions?
As I explained in my presentations before, we couldn't fill these products properly, even though we tried many different nozzles types and adjust the machine several times. None of them worked well. With this new nozzle, the filling works successfully and smoothly. Also, this nozzle will be useful for our new products we have with low viscosity in our another water-based filling area, I mean. And also, I think we gained new technology that we can use other areas too. I think this is the biggest benefit for us.
Perfect. Okay, and here we have also a question for you from the experimental side. How are the designs easy to disassemble for detailed cleaning? So what's your experience, Sila, cleaning these nozzles?
For us, at the beginning, actually, we thought same things because it seems not easy for the cleaning. But yeah, we cleaned properly with our solvent because our filling line was solvent, so we had to clean with solvents. But we cleaned perfectly. We didn't any face issue with this cleaning system.
Perfect, perfect. Sergi, for you, will adapters be required for the non-clamp designs?
In fact, our design is conceived to be used in both technologies, with the clamp and the 3D part. I mean that we have a system designed with this 3D technology that it's allowing to adapt it the same nozzle to be used with the clamp or the 3D. Then we have one design that it's able to be used on two systems. But if you want to use only in the 3D system, no problem, because it's just a matter how to fix it.
Okay. And what about the used materials? Are they compatible with full average of products? The plastic material of the nozzle is compatible with different products?
No, of course, because this is plastic technology, what we are using right now. But we can say that with the materials that we are running, we can cover 90% of the products to be filled. I mean that on that part, at the beginning of our study, it was the same issue. We will be able to cover all the range of the products, but the technology of the 3D printing materials and so on, it's going so fast, and every day we are getting new materials to be used.
Thank you. Thank you for answering. Sila, for you, I don't know if you have manufactured colors, different colors with these nozzles. So there is here a question asking if it's easy to clean the nozzle between different colors.
Actually, we didn't try between the colors. Our product was varnished, so we just clean with our solvents. We didn't try, but I think there will be no problem. You can clean properly your nozzles. But as I said before, we didn't try it between the colors.
Okay, thank you. Here, Sergi, we have one in three questions in one question. And I'm going to the last one because I think that it's probably the more interesting one. Do you expect to gain speed in normal paints, or is only for low viscosity materials?
No, the gain it's for normal and also for the different types of paints. The speeds that we can gain, it could be really interesting. We are getting gains up to, this is realistic, 20% of capacity on the dosing time. Then it means that this technology can be retrofit in a filling machine of OB just to speed up, just placing this part on the machine with the same machinery.
Yeah, thank you. Sergi, I have a question for you about the future of these additive manufacturing technologies in filling equipments beyond nozzles. So, I mean, do you think that this technology would be applied for other parts of the filling equipment?
Carlos, honestly, I think that we have to reconsider this question because from my understanding, this technology is not the future, it's the present.
It's the present, yeah.
Okay, because today we are using some of the parts of our equipment in 3D technology for all the benefits that we are getting to be produced with this technology.
Perfect. Sila, one question for you. What would be your recommendations for other production sites considering testing these nozzles?
If they have products that hard to fill in their filling line, I think they should give the nozzle a chance. It's important to work with close OB and share their product details to find the right nozzle, so they can choose the right nozzles and achieve the best results, I think.
Okay, thank you. So I'm sure that there will be more questions, but we are close to 50 minutes, and our commitment was not to last more than 50 minutes. So let me give you the last remarks. So first, of course, Sila, thank you for your presentations and valuable insights. And thanks to all of you for attending this session today. We hope you found it informative and inspiring as we explore how 3D printing can enhance filling operations in the coatings industry. If you have, of course, further questions or would like to discuss collaborations opportunities, please feel free to contact us at 𝗱𝗚𝗏 or follow up directly with our speakers. Thank you again, and have a great day. Thank you. Bye.
Thank you.
Thank you.
Bye.